Okay, so we're talking about permutations and combinations, and here are the examples that I wanted you to try out first. So the big difference between permutations and combinations is that with permutations, the order matters, and with combinations, the order does not matter. So for a permutation, 1, 2, 3 would be different from 1, 3, 2, and with combinations, 1, 2, 3 is the exact same thing as 1, 3, 2. They both have the same elements in that selection. So the first question is the NCAA has applications from 6 universities for hosting its intercollegiate tennis championship. There are 4 rounds that need to be hosted. How many ways can these locations be selected? So the 4 rounds, there's definitely going to be a first round, second round, third round, and fourth round. Can you interchange the first and fourth round? So the question is, does order matter? In this case, absolutely. Order would absolutely matter in this case. So what we would want to do is, as far as the calculator is concerned, is there are 6 universities and 4 of them are going to be selected. So since order absolutely matters, it's going to be a permutation. So we would, in our calculator, have 6 NPR4, 6 NPR4, which gives us 360. And again, it's because there's four rounds of a championship. There's going to be like a first round, and the fourth round is the most important. So, I mean, there's a layer of importance that goes on for the 4 rounds. So this would absolutely have to be a permutation because first is different from the fourth. Number 2, there are 5 finalists for the Mr. Rock Hill pageant. How many ways can the judges choose a winner and a first runner-up? Again, the winner is different from the first runner-up. So if the first 2 contestants get first and second place or second and first place, those are very different. So this is again going to be a permutation, and since there's 5 possibilities, and we're only picking 2 of them, we would do 5 NPR, 5 NPR2, which should give us 20. In a primary election, there are 8 candidates. How many ways can the president, vice president, secretary, and treasurer be selected? So the president, vice president, secretary, and treasurer is 4 positions. Out of 8 candidates, there's 4 positions. So again, this is going to be very different, that the position they hold is going to be separate from, it depends on who wins.
Mr. Roscoe?
Yes.
Do you have a permission slip for Kennywood?
For you?
Not for me, for Jacob. His parents are waiting, baby downstairs. Oh, how many ways can 5 people line up to get on a bus?
Make it count. Yeah.
I love those. Sorry to interrupt your taping.
That's fine, I can cut it out.
Okay.
Okay, no idea where that's going to cut. But, so whether the president, vice president, secretary, or treasurer, that's very important if candidate, the order matters. Whoever gets president can't get vice president, can't get secretary, can't get treasurer. But if the second person, the order matters in this case as to who gets in what position. So 8 NPR4 is 1,680. Cool. So in how many ways can 5 people line up to get on a bus? Now, as far as my last trip to Kennywood was concerned, the back of the bus is super important. So the first person who gets on the bus is more important than the second person that gets on the bus. So this only says how many ways can 5 people line up to get on a bus. Well, in this case, that tells us that there are 5 people and we want all 5 of them, and order matters. So 5 NPR5 is going to be 120. So there's 120 different ways that just 5 people can line up to get on a bus. 2 bros are planning a vacation to 3 countries this summer. They have a choice from 7 different countries, so they narrowed down all the countries to 7 of them. They have to narrow them down again. How many different groups of 3 countries can they pick? Now, this one, we're only looking for groups of countries. So in this case, order doesn't matter. So as far as what's going on in this problem, they're just looking for 3 different countries. They're not saying we're going to this one first, this one second, and this one third. They're just saying, what 3 are we going to go to? So in this case, order does not matter. So there's 7 countries, and they want to pick 3 of them, but order does not matter. So we're going to be using a combination. So we're doing 7 NCR 3, and there are only 35 ways that can happen. Now, if you want to check it, this would be something interesting. If you want to do a permutation of 7 and 3, 7 NPR 3, you get 210. That's a lot bigger. So that means, and that kind of makes sense, that if I am, the permutation with 210 possibilities is saying that, well, there's going to be more because the order matters. So if they choose countries 1, 2, and 3 versus countries 2, 1, 3 versus country 3, 2, 1 versus countries 3, 1, 2, I mean, there's 6 different ways to organize 3 numbers. And you can check me on that one if you want. So this 35 is going, the combination has to be smaller than the permutation because the permutation has different orders. So there's going to be different numbers of ways that you can do that. But again, we're talking about groups of 3 countries, so this order doesn't matter. For number 6, 45 people run a race. How many ways can the top 3 runners place? So does order matter here? Absolutely. First place is better than second place is better than third place. So 45 NPR 3. 45 NPR 3. 85,140. 140. There's a lot of different ways. There's 45 runners that you can get first, second, and third. There's a lot of permutations. Okay, so there are 15 applications for 4 jobs. How many ways can the 4 jobs be awarded? 15 applications. There are 4 jobs. Now, the 4 jobs, this doesn't specify. So if they're the same thing, this would be a combination. If they're different jobs, it would be a permutation. So this doesn't specify, so we're just going to say 4 jobs. You just want a group of 4 people, and this would then be a combination where order doesn't matter. Now, if you were to come across a question like this on a test and you answered it one way and I thought it should be another way, feel free to argue your answer. Because in this case, that would absolutely be arguably a permutation. But I think a combination fits this better with the way the problem's worded. So I'm going to do 15 NCR4, which is 1,365. So if there's 15 applications and I take 4 of them to fill my 4 jobs, there's 1,365 possible ways that I can do that. As opposed to 15 NPR4, the 32,760 ways that I could fill 4 specific jobs. So that way order matters. So the first person gets a first job, the second person gets a second job. This is saying I want 4 people to fill 4 jobs. If it was more specific, saying I want this person to fill this job, this person to fill this job, and this person to fill this job, and this person to fill that job, then it would be a permutation because the order would matter. However, the way this is set up, the combination order is not so important in this case. Number 8, how many ways can 5 out of 13 students be selected to take a van instead of the bus? In this case, we're just taking a group of 5 and throwing them into a van. So there would be 13. This would be a combination because order does not matter. So I'm using 13 NCR5, which is 1,287. How many ways can 3 softball players be chosen to refill the water cooler? Again, I just need 3 of you to go get water. Order does not matter in this case. 3 softball players be chosen to refill the water cooler. It would be important to know how many there are to choose from. So let's say there's 13 people on the team. So this 13 I'm making up, and I want to choose 3 of them. So 13 NCR3 is 286. So there are 13 people on the team, which I made up. 3 people need to fill the water, so order doesn't matter, it is combination.